So let's start with this particular problem, question number 90. So UGC NET Economics June 2025 में काफी सारे क्वेश्चंस आए हैं from those areas जहां से पहले नहीं पूछते थे. So a lot of statistics, a lot of econometrics, a lot of mathematics has come into this examination right now. So let's take a look at question number 90. तो ये क्वेश्चन है, find the equation of the regression of y on x. अब y on x का regression equation is y minus y bar is equal to beta, that is by x into x minus x. अब हमें खाली वैल्यू पुट करना है. y minus y bar beta yx is minus 0.6643 x minus x bar. अब आपको बेसिकली यूज करना है कैलकुलेटर. 0.6643x minus minus becomes plus. 32 into 0.6643 will be basically plus 221.2576 plus 38 if it goes on the other side. तो ये बेसिकली प्लस है. आंसर आप देख सकते हैं नंबर 4 है. तो ऑप्शन से भी देख सकते हैं, पहला दो तो होएगा ही नहीं क्योंकि ये है ये, एंड प्लस होगा माइनस नहीं होगा, तो ये भी आउट हो सकता है. तो यू डोंट हैव टू रियली कैलकुलेट इट ऑल्सो, बट कैलकुलेट करेंगे तो एग्जैक्ट आंसर भी श्योर आप हो जाएंगे. दिस इज माइनस 0.6643x प्लस 59.2576. आंसर 4. Question number 96, UGC NET Economics June 2025. So the null hypothesis that all slope coefficients are simultaneously equal to 0 is tested in Logit model by what? तो ये इतना easy question नहीं है. You have to know about the Logit model. Now usually ये नहीं पूछते थे ये, but अभी ये पूछने लगे हैं. So कहीं ना कहीं we'll have to think about our preparation. So basically, if we take a look at this, why option 1 is incorrect. F-test is commonly used in linear regression models to test joint hypothesis. Okay. Logit model is a generalized least square model, but यहाँ पर OLS नहीं use कर रहे हैं. The F-test is not applicable because of the assumptions of OLS. ठीक है. टी टेस्ट भी नहीं होगा क्योंकि इंडिविजुअल कोएफिशिएंट्स को जब हम लोग टेस्ट करते थे तब टी टेस्ट को यूज करते थे. ओके. काई स्क्वायर टेस्ट भी नहीं होगा क्योंकि गुडनेस ऑफ फिट यहाँ पर हम लोग नहीं देख रहे हैं. ओके. लाइक्लीहुड रेशियो स्टैटिस्टिक्स is what we basically use in the Logit models. It's called LRT. So LRT, likelihood ratio test, is what we use. It's used to test joint hypothesis about multiple coefficients. Joint hypothesis using multiple coefficients. Okay. The test compares the log likelihood of the unrestricted model to the restricted model. The test statistic follows a chi-square distribution with the degrees of freedom equal to the number of restrictions. तो जितने slope के coefficients है, that many number of restrictions. It follows a chi-square distribution, but the answer will be likelihood ratio statistics, so LRT tests. And it's absolutely standard for testing for overall significance of the model in Logit. Okay. So ये आंसर है. आंसर is likelihood ratio statistics. Right. अब ये वाले क्वेश्चन को देखते हैं. UGC NET June 2025. So indirect least square is applied in the coefficient of a structural equation, over identified equation, reduced form equation, under identified. अब ILS होता क्या है? Indirect least square होता क्या है? So firstly, let's understand that. It's a method which is used to estimate the parameters of a structural equation in a simultaneous equation model. Okay, so the core idea behind ILS is to first estimate the parameters of the reduced form equations using OLS. Then the reduced form equations express each endogenous variable as a function of only exogenous variables or the disturbances. Okay, so only the reduced form coefficients are obtained. So we need to understand what we need to do here. यहाँ पर the correct answer will be the structural equation. Okay, ILS is specifically designed to estimate the coefficient of the structural equations in a simultaneous equation. Okay, these equations represent underlying economic and theoretical findings. Okay, so the relationships that happen, that is what we are looking at here. Over-identified equation is something that has extra variables in it, and that is exactly why it's called an over-identified model. A reduced form equation is basically um, an equation which is uh, basically I am replacing a few variables with instrumental variables and making the equation itself a little shorter. Under identified is if I miss few equations or variables in the equation itself. So that's not the answer. The answer here is a structural equation. So by first estimating the reduced form equation using OLS and then deriving the structural parameters from these reduced form estimates. Okay, so that is what is the answer. Answer is A, structural equation. बहुत तगड़ा knowledge आपका होना चाहिए in terms of distributions in order to answer this question 103 of UGC NET Economics June 2025. Mean of a hypergeometric is n into capital M by capital N. Moment generating function हो गया ये. Coefficient of kurtosis of a binomial 1 minus 6 PQ by MPQ. And variance of a geometric distribution is Q by P square. Here the answer is 2, but it's not a very easy question. Okay, you need to know complete information regarding these distributions. Although options को भी देखकर समझ में आ रहा है क्योंकि ये तो moment generating function ही हो सकता है. Binomial distribution has to include NPQ in it, NP and Q in it. Geometric distribution only has P and Q in it. N नहीं होता है. So answer is B, Bombay. क्वेश्चन नंबर 105 यूजीसी नेट जून 2025. यहाँ पर आपको काई स्क्वायर डिस्ट्रीब्यूशन बहुत अच्छे से पता होना चाहिए. काई स्क्वायर डिस्ट्रीब्यूशन with n degrees of freedom, expectation x is equal to n, variance x is equal to 2n. ठीक है. Beta 2 for a chi-square distribution is nothing but the kurtosis coefficient. Okay. ठीक है. So beta 2 is basically 3 plus 12 by n. Okay, so that is what is matching the answer. ये हो गया beta 2. अब let's go into the skewness. Skewness पे बाद में आएंगे. मोड हमें पता है, तो पहला जो आंसर है, पहला आंसर इज 3. मोड हमें पता है, मोड ऑफ अ chi-square इज n minus 2. So C1 and B A3. इसके बेसिस पर we are able to mark, क्योंकि it's very difficult for you to remember the skewness. Skewness is normally root 8 by n. Okay, यहाँ पर root 2 by n ही ऑप्शन में है. एंड म्यू 3 आपको याद नहीं रहने वाला है, बहुत मुश्किल है. तो दैट्स द रिमेनिंग ऑप्शन. ठीक है, तो रूट 2 बाय एन ही मार्क करेंगे. सो आंसर है नंबर 4. So mode and beta 2 अगर आपको पता है या any 2 अगर आपको पता है, you will be able to answer this. Okay, so answer है 4. But again, your knowledge of chi-square distribution is imperative in order to solve this particular problem. ठीक है, ये expected नहीं था but आया है. So UGC NET में you will have to do the distributions very well. So UGC NET June 2025 114. Again we are going to go into understanding normal distribution very well. तो यहाँ पर let's take a look at कि क्या properties है normal distribution. Normal distribution is symmetric. Symmetric है तो हमें पता है कि the skewness is equal to 0. Skewness is equal to 0 का मतलब है कि central moment, all odd order central moment will be 0. So mu3 will be equal to 0. तो फर्स्ट वाला करेक्ट है स्टेटमेंट. सेकेंड जो स्टेटमेंट है वो है कर्टोसिस का स्टेटमेंट, दैट इज बीटा 2. बीटा 2 फॉर अ नॉर्मल डिस्ट्रीब्यूशन इज not 0. Beta 2 is equal to 3. Okay. Kurtosis is not 0 for a normal distribution. It is mesokurtic. Okay. Mean deviation about a mean for normal distribution is approximately 4 by 5 sigma. It is exactly ये value है 2 by pi sigma, but 4 by 5 sigma is approximately equal to root over 2 by pi sigma. Okay. अब third वाला mu 4, fourth order central moment of a normal distribution. Fourth order central moment for a normal distribution is 3 sigma square. 3 sigma square. It's not 2 sigma square. 2 sigma square नहीं है, 3 sigma square है. तो D भी incorrect है. E, the characteristic function for a normal distribution is e to the power I mu t minus t square sigma square by. This is the characteristic function of a random variable x. Okay. So for a normal distribution, the characteristic function is this. So E is also correct. So A, C and E are correct. And therefore option A will be your answer. So option A will be correct. Okay, next question. Question number 124. UGC NET, June 2025. Again, something to do with estimation and sampling. So bootstrapping technique. Bootstrapping technique is a resampling method used to estimate the sampling distribution of a statistic. Okay, by repeatedly drawing samples with replacement from the original sample. Okay, this technique is particularly useful when the theoretical sampling distribution is unknown or very difficult to derive. वो आपको नहीं मिलेगा. तो यहाँ पर हम लोग एक एक ऑप्शन को देखेंगे. टेस्ट फॉर स्पेसिफिकेशन बायस. Specification bias occurs when a model is incorrectly specified. While bootstrapping can be used in conjunction with certain model diagnostics, its primary purpose is not to test for the specification bias. Okay, वो नहीं है. Obtain the sampling distribution of parameters of interest. अब repeated sampling से your estimation will get better. Okay, so you will obtain the sampling distribution of the parameters which are normally mu and sigma. So number 2 correct है. Test for autocorrelation. Autocorrelation refers to correlation between observations of a time series in different points of time. Basically error का autocorrelation का बात यहाँ पर कर. Durbin-Watson test, Brioche-Godfrey test, Lejeune-Box test. Okay, so these are a few tests that are used to test autocorrelation. Okay, test for normality of error term. Normality tests like Jark-Bera, Shapiro-Wilk, many more. They are used to check if the error terms in the regression model follow a normal distribution or not. So bootstrapping से उसका relation नहीं है. The primarily and most fundamental use of the bootstrapping method is to approximate or obtain the sampling distribution of the parameters like mu and sigma. ठीक है, तो यहाँ पर the answer is B, Bombay. Number 2. Okay. UGC NET June 2025. Again, an extremely statistic oriented question. आपको MGF आना चाहिए in order to know this. अब ये Poisson distribution के MGF क्या होता है? Poisson distribution का MGF is basically e to the power lambda e to the power t minus 1. ठीक है, तो पहला वाला तो बाइनोमियल डिस्ट्रीब्यूशन का MGF क्या होता है? बाइनोमियल डिस्ट्रीब्यूशन का p इंटू e to the power t प्लस q होल टू द पावर n, ये होता है. ओके, सो राइट, हाँ, सो दिस इज व्हाट आई मेंट e to the power t minus 1. ठीक है, अब इफ यू टेक अ लुक एट दिस, ये तो बाइनोमियल डिस्ट्रीब्यूशन का टाइप है. ये बाइनोमियल डिस्ट्रीब्यूशन है. इफ आई टेक p is equal to q is equal to half, तब ये आ जाएगा. सेकेंड वाला, ये थर्ड वाला लैम्डा इज इक्वल टू 3 में ये आ जाएगा. यहाँ पर लैम्डा इज इक्वल टू 1/4 में ये आ जाएगा. बी सी एंड डी, ये टू द पावर -2 कहाँ से आ गया? टू द पावर n होता है द नंबर ऑफ टाइम्स दैट यू परफॉर्म एन एक्सपेरिमेंट रिपीटेडली. ओके, तो ई भी नहीं है, आंसर इज बी सी एंड डी. बट इसके लिए आपको एमजीएफ आना चाहिए. Movement generating function is again something that we have to focus on in the UGC NET preparation. UGC NET question number 133. Again, you need to know these tests in order to answer it. So, सबसे पहले spurious regression क्या होता है? Spurious regression occurs when two or more uh, series that are not related but statistically आ रहा है कि related है. This can happen because of trends in the series, non-stationarity of the roots. Okay, so this leads to misleading high R square values. Now, Granger and Newbold in the year 1974, they devised a rule of thumb in order to identify spurious regression. They basically said that if R square is greater than D, where R square is the coefficient of determination and D is the Durbin-Watson test statistic. So if this is greater than D, then you should suspect spurious regression. So a high R square would indicate a very good fit, and a low Durbin-Watson statistic would indicate severe positive serial correlation in the residuals. That is the error term, okay, which is obviously a way to say that there is misspecification problem in the regression itself. Okay, it occurs basically when non-stationary series are regressed with each other. Okay, and this is the case which leads to spurious regression. The Durbin-Watson statistic approaches zero as the sample size is increasing more and more. Okay, so a very high R square and a very low Durbin-Watson statistic, that is what identifies with this. So here the answer is 3. R square and low Durbin-Watson statistic is what will identify. Okay, so this is how we identify spurious regression. UGC NET June 2025 135. This is very easy. Poisson variate e to the power minus lambda lambda to the power x by x factorial. Now, if I go for x plus 1, तो क्या होगा? e to the power minus lambda lambda to the power x plus 1 divided by x plus 1 factorial. Now, if I have to write it down in terms of px, how will I do it? Lambda e to the power minus lambda lambda to the power x, because lambda to the power x plus 1 is lambda to the power x into lambda. X plus 1 factorial is basically x plus 1 into x factorial. Okay, so basically क्या आया? Lambda by x plus 1 e to the power minus lambda lambda to the power x by x factorial. Now this is my px. तो px plus 1 क्या हुआ? px plus 1 हुआ lambda by x plus 1 into px. Answer first option. UGC NET Economics 2025, again, sampling and estimation question number 138. Management of a manufacturing firm wishes to determine the average time required to complete a manual operation. There should be 0.95% confidence. So a 95% confidence interval is basically x bar plus minus 0.95 z alpha by 2 into sigma by root n. Now, will not exceed 2 minutes. तो ये जो error है, ये will not exceed 2 minutes. Okay, so less than equal to 2. And 95% confidence interval के लिए z alpha by 2 is 1.96. Studies expert is saying 16 minutes, so this variability is 16 minutes. I need to find out the sample size. So 16 into 1.96 divided by 2 less than equal to root n. So अगर इसको calculate करें तो आएगा n greater than equal to 245 point something something. So sample size that you need is basically at least 246. Okay, 245 point something something आएगा. You will mark 246.